Hello everyone, and welcome to another episode of Biochemistry Capstone Videos. I am Spencer Hall, and I'm going to graduate someday. Today we're going to talk about segregation in science. And by that, I do not mean the way that people refer to it in society, such as discrimination or treating people wrongly or less because they're a specific gender or a specific race or they have a different hair color than I do. Instead, segregation science, in my case, refers to chromatography. And chromatography is the process by which we separate molecules based on given properties. And so there are several different options we could do that with, but the idea in this case is not at all to lessen the worth of one, but rather to use its strengths or to highlight them, to have them separated so we can use them for even more. So knowing this purpose, let's begin with a type of chromatography or one property that we could separate molecules based on. A very common and easy one to explain would be size. So if we have big molecules in a solution or in a compound, and you have some small ones, and you have some medium ones, you have another big one maybe, a couple small ones, a couple medium. All right. What chromatography would do is separate certain molecules into different locations. Here, here. Let's see how the medium-sized ones came over here, the large ones here, and let's just make the small ones come down here. Like that. And so now what you'd end up with, the two big ones over here, well, that doesn't look medium. Medium, 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 medium. How many do? 3. And then over here, you have your 4 small ones, right? So a good question to ask is, one, what would the purpose of that be? Again, it would be using these molecules that you're searching for in your solution rather than having all of these come in when you're only looking for specific ones. You might also wonder, how exactly does this happen? Do you have some method to get big molecules somewhere and to get medium and small ones separated? And there could be all sorts of different sizes. And the answer is yes, and here's a good way of how it looks. There's a tube in chromatography that contains a lot of beads. Beads are not the molecules over here. Instead, they only blow up one to show what it looks like. This is just one of these beads, and it can have little pores on them. It has many different properties, but we'll have to use pores for now, and maybe like a little tunnel. And the fact is that when you pour your solution of all of these things into here, different sizes in this case are going to take different lengths of time to get through. And this will have a little opening where things can drip out. And you would expect to have a vial to catch so many right here. And after you catch so many drops, this is kind of a slow procedure. You would shift it away and you send this next one into that spot to collect the next few drips. Why would you be doing this? The large ones are very well expected to cruise straight through these beads. Why? Because the small ones, or maybe the medium ones, mostly the small ones, will be getting caught up in all these little beads, in little pores or in the tunnels, and these things take time for it to go through. Or in other words, the distance traveled for the small ones is greater than the distance that would be traveled for the medium ones or the large ones if it's using the tunnels, and the time would be increased no matter what if they just got stuck in these little pores. Now, lest you think that size is the only thing that we separate by, there's actually many more. So we have hydrophobic and hydrophilic properties. So over here, all right, hydrophilic. Now what does this mean? Water loving, or in other words, polar. And then we have another one right here. Hydrophobic, this would mean almost exact opposite, water fearing. or in other words, non-polar. Now, instead of your beads having maybe tunnels and pores, perhaps they have a property that they share with one of these. Perhaps they are hydrophilic. And we expect certain molecules to take certain different lengths now to get through, because these properties would separate them apart. And lastly, even in the hydrophilic region of polar, we have positive and we have negative. And so you could use different beads that are, say, for example, positive, put through something that has positive and negative molecules or atoms, and you would expect the positive ones, which hate being around their own kind, they repel, opposites attract. You would expect the positive to make it through very quickly if these beads are positive, while the negative get caught up with all the attractions, right? Using the same little vials to catch different drops, you would start seeing different tendencies from those. So hopefully this has been able to help you get started with understanding chromatography and how focusing on the strengths and the differences of molecules actually pays off really well in this case. Thank you for watching.